All right, welcome back. Today we're going to be talking about association, how points relate to one another in statistical data. So again, our learning target's going to be the same one we've been learning all week, to construct and to explain scatter plots, mainly more of that explaining part today. Our success criteria is going to be to identify if a scatter plot is positively, negatively, or has no association. We're going to talk about those vocabulary words and how to use them, how to describe them, how to describe scatter plots using those certain words. And our success criteria, second success criteria is going to be to identify if a scatter plot is linear or nonlinear. These two terms are not new. We actually talked about linear versus nonlinear when we talked about functions. So we're going to apply that same type of straight line versus not straight line idea to our statistical data. Let's take a look at the key idea here. We have three vocabulary words: positive association, negative association, and no association. On your notes, you have three different grids. So the first grid that you see is labeled positive association. A positive association, you're going to see the points gradually drifting upwards as you read the graph from left to right. So I'm just going to put some random points on here. I'm not taking it from any statistical data. I'm just plotting some random points, but I'm plotting them in a way where it looks like the points are traveling upwards from left to right. I like to think of data as kind of like being like people walking down the street. You could have a parade of people where they're more burst out. Like I can keep filling in more points where maybe it's a kind of a big street looking type thing, but they're all kind of still going in this general direction as you read the points from left to right. Or you could even have them where the points are a lot more close together, almost in a single file line. Okay, so something like this. Maybe 1 or 2 points, not so perfect, but it's still trending upwards from left to right. That would be a positive association. A negative association, okay, so the second graph you have labeled there says negative association. And that's going to be the opposite idea, where we see the points traveling downwards from left to right. So again, I'm just going to put random points on here just to illustrate that they can be anywhere. You can take data from anything and have these points trending downwards from left to right. Okay, so I'm seeing they're going down from left to right. They all seem to be going to the same place. If you read the graph from left to right, it looks like they're traveling in the same direction, but downwards, and that's why it's a negative association. For the third graph that you guys have, it is labeled no association. Okay, and when something has no association, that means you don't really see the points trending upwards, trending downwards. It just looks like a big splatter of points. So I'm just going to make an example of this, putting random points down, but really I don't want them to look like they're following any type of path. I just want them to be exploded all over the graph. I can't really tell if they're going upwards, if they're going downwards. It literally looks like a paintbrush was just splattered all over this graph. Okay, so positive, they travel up from left to right. Negative, they travel down from left to right. And no association means you can't really tell what those points are doing. So let's take a look at the first example. Here we have biologists recorded the lengths and weights of several wild alligators. We're going to make the scatter plot to represent the data and then answer a couple questions. Does an association exist between the lengths and the weights of the alligators, and explain? And then we're going to predict the weight of an alligator that is 58 inches long. Pause the video and plot these points down. Your graph should end up looking something like this, which I can tell the points are kind of traveling along what looks like this path, which is upwards from left to right. So I'm going to describe that in my association. This is a positive association. It does say to explain, so I'm going to write why. Because the points go up from left to right. Okay. Second thing we were supposed to do, it says predict the weight of an alligator that is 58 inches long. Okay, now when we make this prediction, you want to pick a point that's following along this same path that I drew. But let's locate the 58 inches long. That's about right there. Okay, that's about 58. I'm going to make a little dotted line all the way up to where the rest of the points are. And if I actually use the line that I drew, I can make a pretty good prediction. Let's say right there. That's a good predictive point. Looks like it's in the same type of pattern as the other points, traveling upwards from left to right. It's not straying away from the pack. And let's make an estimation on that. I would say a 58-inch alligator would be roughly about 34 pounds. So my prediction, a 58-inch alligator would weigh about 34 pounds. Okay, and we make that prediction because we predict according to points that would follow along what all of the other points are doing. So that would be a pretty good prediction. If you picked something up here, like weighing 50 pounds, I don't know if I would agree so much on that one. I think it's not quite following along the rest of the points as well. Or if you maybe predicted something way down here, again, that doesn't look like it's following the rest of the path. It looks like it's straying away a little bit, so I wouldn't consider that a very good prediction. Let's have you guys give this a try in your U-Try. Plot these points down on the grid that you're given. Then describe an association, positive, negative, or none, and make sure you explain why. And then make a prediction about a bass that is 19 inches long. Alright, so in many cases you can analyze two data sets before you graph them and determine whether a scatter plot of the data would show an association. So we're going to consider the relationship between the distance a student lives from school and the time it takes the student to get to school. Now, I usually just put a couple of arrows indicating if one thing is increasing, so if the distance a student lives from school increases, then that student lives further away, and thus it would take them longer, meaning the time it would take would also increase for the student to get to school. Now, if you have an increase and an increase, that's like a positive and a positive, which would result in a positive association. The graph would look something like this. Okay, so as we would read it from left to right, we would see distance away from school increasing the time as it went by. So that's why it would be a positive association. However, if you ever have, and you always want to start with, what if the first thing you're talking about increases? If you start with thinking about if the first thing increases, but then the other thing that you're talking about is decreasing, that's like a negative. Okay, and think about that like multiplication. A positive times a positive is positive, but a positive times a negative is going to be a negative association. Okay, so keep that in mind when you analyze these different situations. So let's take a look at the first example. We're just going to write whether each of these scenarios has a positive, negative, or no association. So the first one says number of songs on a CD and the cost of the CD. If the number of songs goes up, then I would assume, since there's more to the CD, that the cost would also go up. That's a positive and a positive, so that's a positive association. Second thing, speed increasing. Okay, so you're going faster, and the distance traveled. Well, if you're going faster, you're going to end up covering more ground. So that's a positive and a positive, making a positive association. Third scenario, size of the TV screen. So if the size of your TV screen increases, what happens to the number of channels? Well, those two things aren't actually related. The number of channels is something that you choose. Doesn't matter how big the TV screen is that you're watching it on, you still will have the same amount of channels. So this actually has no association. And then the last scenario, size of a family. What if your family size went up? So the number of people in your family increases. What happens to the water bill? Well, more people are going to be using water, so more water is going to be used, and thus your bill is going to increase. So since that's a positive and a positive, that would be a positive association. Go ahead and use this type of analysis to see what kind of association is in your U-Try. Alright, so I have one last example for you guys, but first I need to intro you with the idea behind this third example. And we can have not only a positive, negative, or no association, but you can say if something is a linear association or a nonlinear association. So if you see in any one of these graphs that it looks like they're following along a straight line path, that's why it's going to be called linear. But you're going to use both adjectives now when you describe what the association is. So we can see in both of these graphs whether it's a single file type of data or if it's a little more spread out, that these are both positively associated. That's why they have the word positive there. They also look like they're following along a straight line. So this is a positive linear association. So same would go if you had a negative linear association. So whether it's kind of more of like a single file or they're a little more exploded, they look like they're following along a negative associated path. They're decreasing from left to right. They also look like they're following along a straight lined path. So that's why it's a negative linear association. Same type of thing would go for something like a nonlinear association, but that would make it like the points are following along a curved path. Okay, so both of these I'm just showing where the points look like they're following along. So if you see that they look like they're on a curved path, we would say that that's a non-linear association. Something like a no association would not be considered linear or nonlinear because there's really no path that you can trace with something that is no association. So let's take a look at the third example. It says the graph shows the number of medals won and the number of Olympic Games participated in by top medal-winning male Olympic athletes. Describe any clusters, outliers, or associations that you see in the graph. I do see here one cluster right there. And I'm going to say it's between, looks like 2 games and 4 games, as well as 10 medals and 16 medals. So I'm going to describe that as my cluster. Cluster between 2 and 4 games and 10 and 16 medals. I also need to describe the outliers. Okay, I see two outliers right there and right there. So I have outliers at, looks like 8, 10, and 8, 13. And then we just need to name the associations. From what I see on this graph, I'm not seeing really a clear association. I don't see the points traveling upwards from left to right. It just looks like a big blob with two outliers. It doesn't look like it's traveling downwards. And it doesn't really look like it's following any type of curved path either. It just looks like a big group of points with two random outliers. So this would be no association. Go ahead and use this type of analysis in your last U-Try. That wraps up today's lesson. Again, our learning target was to construct and explain scatter plots. Today, again, focusing more on the explain part. And the way we were successful today was identifying if scatter plots were positively, negatively, or have no association. We did that in all three examples, so examples 1 through 3. We also identified if a scatter plot has a linear or non-linear relationship. We did that one in example 3. Go ahead and grab your practice, complete it, and ask any questions if you have them.